let's go to our speaker is Dr. Miliana Siqueira from University of Sao Paulo, Brazil. Miliana will introduce for us today a topic which is Brazilian coconut husk fiber as a fiber potential textile raw material. Dr. Miliana, are you here?
Yeah, she's here. I'll give her ghost permissions right away.
Okay, yeah, go ahead.
Hi.
There you go.
Hi, can you hear me?
Yes, we can hear you. I can hear you clearly myself.
Oh, thank you.
Yes, me too.
So can I share my screen?
Yep, you have ghost permission, and you have the floor. Go ahead.
Just a minute. So here,
as a co-host, that meaning that you can have the hand to screen your presentation by yourself.
okay, so just hear me.
Go to.
Oh, yeah, I think I get it. So are you seeing my screen? How?
You are not using PowerPoint.
It's
Okay.
full screen. It's full screen.
Okay, yeah. Yeah, we got it now. Okay, good. You're good to go. Okay.
Hi, I am Lena. Greetings from Brazil. So today I'm going to present my research that is in development that calls Brazilian coconut husk fiber as potential textile material. These are the authors. We are from University of São Paulo, Brazil. It's a great pleasure to be here. So Brazil is the 5th largest producer of coconut, where this activity generates about 7,000 million tons of residual coconut husks per year, while this inadequate in destination causes contamination. And the demand for natural fibers in the Brazilian textile industry, which is dependent of petrochemical research, has increased the need of new materials from renewable researches for bioproducts. And this high volumetric waste with increased environmental awareness makes the appropriate textile technologies and materials a priority. And the use of these agro-industrial residues is an opportunity to generate value. So this research aims the analysis of coconut fibers as potential textile material in Brazil. So the research methods. In this research, we use bibliographic survey and analysis by systematic literature review, followed by bibliometric analysis. So to get the base of the coconut fiber, we use as the variations of some terms, and this research was limited to Brazil. In this review process involves aspects of planning, execution, and analysis of results. So since literature research, through systematic literature review and bibliometric analysis, and later we're gonna do the laboratory tests and some interviews. So results and discussion, we're gonna pass the textile sector, fiber consumption, understand the textile sector in Brazil, think Brazilian coconut scenario, and its applicability. So textile sector, it's now continuous innovation by technology development of materials in polymerization and fiber technologies and market and consumer demands. The size of the global textile It's right now by $100.3 billion. And in Brazil, we are the 5th largest textile industry in the world, in the most complete chain in the West, from fiber production to retail. So the fiber consumption, there is evidence, as you can see, of increase in fiber by more than 30% to a lot of mainly global fiber production with emphasis in synthetic fibers than natural fibers. So this impact of procurement, treatment, and production of textile material to achieve this better growing conditions and optimal fiber quality, the contamination from chemicals and artificial fertilizers are carried into the soil, air, and water. So considering also the phase of production, but also the phase of use, the life cycle of products as a major environmental harm because they are too small, and at a global level, textiles are like in less position in terms of recycling. So sustainability in textile sector has become a crucial factor in the textile industry, increasing the concern to produce materials that meet environmental and social demands. So the materials have been great precursors of this new perspective, and the textile industry acts frequently in 14 of the 17 SDGs, progress in the development of mainly polymers and fibers from this renewable biomass. And currently, the industrial system in Brazil still do not cover the closing of the cycle efficiently, and design concepts for circularity so are incorporated in the textile industry. So Brazilian biomass scenario, Brazil is a great biomass generator. Agro-industrial residues are still underutilized, destined for natural decomposition. So these lignocellulosic materials represent 60% of the plant biomass. So here in this table, we can see our biomass offered since agricultural waste and agro-industrial waste to 2030. A high increase. So Brazilian coconut scenario, production is carried out by small and medium-sized family farming producers, to a lesser extent by a larger agribusiness company. So productive is very diversified and of great social significance. Just a minute. The world production of coconut is concentrated in 3 countries. Brazil occupies the place of 5th largest producer, participating in 4.75% of the global production. So genetics, coconut culture has great specific variability, but in the Brazilian coconut, the variability is small to the existence of a single species and with only 2 varieties. So coconut genomics work is a 100% origin in Brazil. These varieties and diversities are giant coconut, dwarf coconut tree, and hybrid coconut. So giant coconut estimates to occupy 7% of the Brazilian territory, like the dwarf variety occupies 20%, and hybrid coconut occupy 10%. The production and the sale of coconut follows different flows from the main producers in the global markets. Brazilian crop are intended for the production of dried coconut in natura, such as coconut milk, grated coconut, and coconut water. And sustainable use, if the crop is improperly grown, it can intensify erosion. But studies, when not direct to the use of fiber, show that the treatment of coconut residues is aimed at transforming into fertilizers and organic compounds. And post-consumption and coconut processing residues are considered inevitable, so therefore they do not change the structure of the food chain. In Brazil, green coconut husks have late technology compared to mature coconut. So these are some economic aspects. Considering the area harvested in Brazil, they generate like almost 3 million direct jobs along the coconut production chain. So they are small farms, farming using semi-extractive production systems, and the production value of almost 1,000,000 reais or local. and like almost 2 million fruits, a lot of. The intensity of consumption can be defined by climatic seasons, summer, autumn, spring, and winter, and the northeast region is the largest producer. The volume of coconut water reflects through imports, so the importance of the coconut water market in Brazil, and these exportations were made to 41 countries. And the coconut, this volume generates a lot of residues. There are almost green coconut. So the applicability, the residual byproducts of coconut cultivation, the hard fibers, were used in manufacture of products with low added value. So the thinner and short fibers to mattress padding, the medium length applicable to textiles, and hard fibers to brushes and brooms. In fact, in Brazil, it's commonly applied in gardening and decorating substrate. So as you can see, there is no wide applicability of the material in Brazil in textile industry. So here are some of the possibilities as automotive industry biocomposites. So when it's about textile applications of this green coconut fiber involve the furniture, footwear, design of home objects, composites, paper and packaging sectors, as well as other areas such as civil construction, museums, and geotextiles. And when analyzed the database that was generated in this research, the scientific literature database analyzed by network built with a vast software by University Leiden. This network was built by the analysis of 59 articles and co-occurrence of 921 specific expressions. So currently the 5 registers are biosorbent for textile dyes, handicrafts, green composites, and copolymers. And the highest co-occurrences you can see in the figure, it's adsorption, tensile strength, textiles, and enzyme activity. The main formats demonstrate the need of expansion of this textile incomes in coconut fiber as raw material. In the Brazilian coconut fiber, currently application studies involve activated carbon producer, carbon sources and surfactants, agricultural substrate, biodegradable and bio-based composites, bioethanol production, biomaterial and bioresource, biorefinery, and cellulose nanocrystals, conditions, additives, thermoconductor, copolymer design, footwear, enzyme immobilization and production, fiber cement, gardening, craft and briquettes, healing and surgical suture applications, oil, foils, and other biosorbents, polymeric, micropolymeric, and hybrid composites, reinforcement in polymeric matrices and biofilms, spinning and wave for use in textile applications, synthesis of lignin nanoparticles, sound absorbing materials, textile and influent biosorbents, biodegraders, woven, non-woven composites. So as a conclusion, the development of appropriate technologies for these materials reduce the sector's negative impacts and increases eco-efficiency, generating ecological benefits from land use through extraction of non-renewable resources, and the employment of fibers is a cheap, accessible, and widely available alternative, and the reallocation of agroindustrial materials in the textile industry still shows incipient advances in Brazil. So we are working in this research, and the main areas identified address materials such as biosorbents for industrial effluents and reinforcement material composites. And in general, these research are advanced in sugarcane, coconut, banana, and pineapple, but we are also studying acai, rice, wheat, and corn. Also are highlighted for retaining the wool fiber of the material. Coconut fibers, they stand out to the intense abundance of residues and the physical chemical properties of high quality, low cost, low density, and biodegradability. And the industrial applicability of fibers in Brazil is small, almost null in the textile sector, while this availability is growing, neglecting the potential to expand effective research structure. but the resource directed to the textile industry presents a larger incidence focus on treated influence than apply it to new materials, constituting scientific opportunities. So this scientific investment in research on materials and technology development are necessary to provide applications that can meet the current and future demands and expand the scope of new materials for sustainability. So I would like to, with the support of the Coordination for the Improvement of Higher Education Personnel of Brazil, and the authors are grateful to Rush or University of São Paulo. I would like to thank my Palma for the opportunity to present this research. These are some of the references.
Thank you very much, Melina. Thank you for such interesting presentation. And by the way, do I pronounce your name right, Melina? Or
Milena.
Milena, right? Milena, yeah. So the floor now is open for questions.
Thank you.
The coconut is very delicious. It looks like the images that you are presenting.
Yeah.
So,
thank you. It's my email. You might contact me.
Yeah. Next year we hope to get when we have the conferences physically, maybe you get some samples.
Yeah.
Yeah, I have just one question. You know, as a textile engineer, and according to previous experience with coconut fiber, usually coconut fiber is coarse and it's not fine. I mean, the diameter is a little bit higher than compared to like cotton or wool. So usually the best form, textile form for coconut is the non-woven. I mean, you cannot do yarns or go to fabrics. It's gonna be difficult. I mean, the only thing that you can do it with coconut is non-woven or coarse ropes, like you know, coarse high count yarns. So did you try anything? Maybe the Brazilian coconut is a little bit different, is getting fine fiber or something like that?
So yeah, we are, as I said in the beginning of the presentation, we are starting this research. So we are knowing the material first after we go to laboratory analysis. So we're gonna do the characterization and analysis of the fiber and the extraction. Most of the problems are in the extraction of the fiber. So we're gonna work on that in the extraction of the fiber, so we can take the better of the fiber. And after of the analysis of characterization, we're gonna try really to do some yarn. There is some research that already aimed at the yarn and the fabric with cotton is 30%. I already studied that can be around 30% of coconut fiber inside 10%, 70% of cotton. So it's a possibility. We think that first of all, we gotta understand our material and the analysis of the characteristics of the material that we have. So we are just in pandemic situation, so we didn't. It's a long research. So ending this part, we're gonna go to the laboratory and start this process. But yeah, we aim the yarn and it may be the fabric. So and we're gonna see maybe next by Palma Congress I can bring some.
Thank you very much. Waiting for your samples next year.
Maybe we have just one question, Professor Ahmed.
Yeah. Oh, okay. Yeah.
Okay. As you know, that the chemical composition, we have many fact from natural polymer, natural fiber, that every year we can get little bit different between lignin and cellulose and everything. How you can have a good material from textile and taking that the chemical composition is different from year to year.
So I don't know if I understand completely, but the chemical composition, we are studying some databases that we have in Brazil. So yeah, we know that lignin is a higher incidence in coconut fiber, but we are studying.
That meaning, for example, like you today, we're working with coconut from Brazil and Professor Ahmed from Egypt. Do you think that at the end we can get the same property for materials?
No, because no. We have a lot of different incidents because of the mature coconut, the green coconut, the place that will grow, the soil, the water. These all things influence in the Brazilian coconut from another coconut. Obviously, we can get a background to study. Obviously, it's a great study that you can analyze to. Oh, sorry, someone is asking here. An effect of the mechanical properties of the material. Yes, obviously.
Yes.
Okay, obviously, but we are still studying because of the pandemic situation. We didn't go to laboratory tests yet, so we are still on research. But yes,
I think also, I'm sorry, Milana, but I think this is a variation in the natural, for properties of natural material. This is actually one of the biggest problem for all natural material, natural fiber. Even here in Egypt, I'm not talking about the difference between country to country, even within the country. If you implant a cotton, for example, in North Egypt, it will be different from the cotton who are implanted in south of Egypt. So usually how we overcome this in textile industry, we overcome this with blending. We usually in the factories we get cotton from different places, and we keep that. We cannot process lot by lot. No, we blend between the lot. If you have a lot coming from North Egypt and another lot coming from Middle Egypt and south of Egypt, so we mix a lot between and we ensure the mixing. Actually, the mixing stage in textile industry, especially in the fiber industries, this is very, very important to overcome a little bit the variation problem between the products. Okay, thank you very much for the title of the